All right. Hydrostatic pressure and osmotic pressure. Osmotic pressure is the same as osmotic pull. So when we say intracellular osmotic pressure or intracellular high osmotic pressure, it means that there's a more concentration of the solutes inside of the cell compared to what's outside. So intracellular osmotic pressure, water will move towards highest concentration gradient of a solute. If we say intravascular osmotic pressure or intravascular high osmotic pressure, it means there is more solutes inside of the blood vessels compared to what is outside, which is the interstitial space. So the water will move towards the highest concentration gradient of a solid. If there is an interstitial osmotic pool, so it means there's in interstitial space, there's more solutes compared to what's in blood, or let's say compared to what's in cells. Even though hypothetically there's no change of solutes within the cell, hypothetically it's constant. So interstitial high osmotic pressure or osmotic pool, it means that the water will be attracted towards highest concentration gradient of a solute that is here. So, and when it comes to osmosis, we say it has a pool, right? High osmotic pool, high osmotic pool, high osmotic pool, or just a pool. With hydrostatic pressure, it is the pressure that is applied on the walls of the blood vessels. So usually it is outward, but let's say there's a lot of water outside, so there's a high interstitial hydrostatic pressure. Here is the high intravascular hydrostatic pressure, right? And we try to maintain pressure. Obviously, there's a ratio, not necessarily should be equal amount, but there's a particular ratio. But you can also say if there's this interstitial space, right, and there's more water here, so it's a high hydrostatic pressure applied on the walls, so outside.